but he's gone on to do great things. So I want to remind you that in 2 weeks, is it 2 weeks? On December 1st, we have a talk by Katie Sayers. Where did I put her talk title? Is Loneliness and Health, Insights from the Chimani Health and Life History Project. And she will be in person. So everyone try to meet here unless you have a contagious disease, be here. And there will be individual signups and dinner and all the usual stuff. All right, I'm going to turn it over to Bret. He has pre-recorded his talk, and we will play his pre-recorded talk, and then he will answer questions at the end. So try to hold your if you have a desperate clarifying question, maybe write a chat to Bret directly, and he can monitor that. And otherwise, we'll hold questions till the end. Ready?
Solar power. Hi, everyone. Thank you for coming, and I really appreciate being invited. Thank you in particular to Susan. There's a ton of amazing talks on the Beck YouTube channel over the years, and it's really an honor to be included in this group of scholarship. So I'm going to talk today about my work on the topic of cultural evolution here at the Max Planck Institute with my research group, the Mosaic Group, Models of Sociology, Art, Information, and Culture. If you'd like to know more about me, you can visit my website, babeheim.com, but I'll also give you a very quick intro to my interests. So I was an undergraduate history major, and I was always interested primarily in the topic of cultural change. So on the top left, we have a rendition of the arrival of the U.S. Navy in feudal Japan in 1854 with Commodore Matthew Perry. As you may know, this led to the opening of Japan to Western trade and industrialization. And on the bottom, we have a rendition of the surrender of Qing China to the Japanese Navy in 1894 during the First Sino-Japanese War. The Japanese are depicted here on the left. So you can see even in just 40 years, there's been a tremendous transformation technologically and socially of Japan. But of course, time waits for no one. And despite the fact that in the 1900s, we saw the ascendancy of countries like Japan and the United States and Europe, today, of course, we see China emerging as a dominant technological power, especially in terms of renewable technologies like solar power, which is, of course, a hot topic at the moment. So zooming in a little bit on this topic of cultural change, we can also look at like micro-level changes. Growing up in California as a kid, I remember the topic of marijuana being something that was both illegal at the time and quite unpopular. The view that this was a good thing, that it was not available publicly. There was also a major age stratification here, of course. Young people were generally more pro-marijuana than older individuals back in the early 2000s. And that remains to be the case today. I mean, if you look at opinion polls as recently as 10 years ago, there's still a significant age stratification. But what's interesting is that, you look at this number and you imagine that time has progressed a little bit. We're actually referring to the same cohort of individuals over the course of time. So clearly cultural change isn't just a matter of people changing their opinions or adopting new technologies or practices. It's also a generational process. We have cohorts in the long run that change with time, and that could potentially be an important explanatory force. So I work in the framework of what's called cultural evolution, which is a field, an emerging field, that is organized around using the basic principles of Darwinian evolution to understand cultural change. And I think it might be worth spending some time understanding why we use this phrase, cultural evolution. Why can't we just talk about cultural change or, describe it as quantitative social science or human behavioral ecology or something like that? What work do we get done as a result of using this particular framework? So my first answer to this question is simply that the phrase cultural evolution is a signifier of a community now of scholars. It's an emerging field, has its own society that's meeting this year or next year in Rabat in Morocco. And it has a really unique and interesting origin coming out of the sociobiology controversy in the 1970s and specifically looking to connect biological and social sciences together, but in a formal, rigorous way. At the same time as pushback against views that behavioral differences between different human societies are due to genetic differences, and this idea of genetic essentialism, which was quite popular at the time that cultural evolution emerged. And these two things together, I would say, have led to the growth of a very positive and healthy society of scholars. And so for that reason alone, I think that there's a lot of value in just talking about cultural evolution as a topic. But really, you can get into the actual content here in the foundational texts on cultural evolution and see that there is quite a bit of unique theory as well that you wouldn't find in other social sciences, and to some extent is apart from the kinds of evolutionary theory you see in genetic evolution. And a major focus, I think, looking at the work in comparison to genetic evolution or other fields like mathematical epidemiology, is that there's an integration of decision-making and cognition in a way that you wouldn't see in other fields, specifically in the form of things like the social learning biases. What kinds of heuristics would you expect to see in an organism to try to acquire useful information socially? As a starting place, it leads to all sorts of interesting phenomena. in models of cultural evolution. And for that reason also, I think you get a lot of value about talking about it as an evolutionary process. For me, though, I think the single most valuable contribution from taking an evolutionary point of view is that we can access the existing tools of evolutionary theory, and I think ground a lot of our understanding of cultural change in the idea that it's not just an analogy when we say it's cultural evolution. It's not analogous to Darwinian evolution. It is Darwinian evolution. Like, it's a form of Darwinian evolution in its own right. And you can see that, I think, most clearly with the concept of population thinking, which Ernst Mayr said was the single most important contribution in Darwin's original framework. The idea that if you want to understand why something is changing in a population, like an average, the average beak depth, or maybe the opinions on some topic in a public opinion poll, really what we're doing is we're tracking a distribution over time, a distribution of individuals and what's happening to those individuals. And when we enumerate all the things that could happen between two time points that cause the distribution to change, we're actually giving an explanation for what's going on, at least to a first order, an explanation for the reason why you see this change. And that's applicable to both culture and to genetic evolution. So let me develop this a little bit more with an example, hypothetical example. So if we imagine there's some trend that we're tracking, maybe NFTs, we can think about those. Remember those? We imagine over time there's some spike in popularity in something that we're measuring, opinion or a practice, a technology, a belief, behavior, something. And then in the fullness of time, it also decreases as well. So we see the increase and the decrease. We can use population thinking to understand, at least to a first approximation, that there's many different processes that could produce this trend. And you can see this, I think, in these two sort of very stereotyped examples here that imagine that we have a population of individuals. We're graphing their lifelines over time here. So this is when they enter the population, and when they leave is the end of their line. And then we have some kind of measurement or production emission from the individual. If they're writers, maybe it's the publication of a book, or if they're academics, it's a paper. I don't know. So this trend could be increasing if we're measuring the red trait here, potentially because we're seeing the arrival of a cohort that's coming in at a particular time, and they all use this trait. And they do so mostly throughout their entire lives. So they're very consistent compared to other cohorts who don't use the trait. And then as the population ages and this cohort starts to move out and new individuals come in, the trend goes down as a result. So that's one potential explanation, is that there's a cohort process. Another possibility is that the arrival of the trend is actually happening across all the age categories, that individuals who are the oldest members of the population or the youngest members of the population are all adopting this this trait that we're measuring. And just as quickly, they're abandoning it as well. And so that could also lead to exactly the same trend. And if we have an understanding of which of these two things is happening, we can start to get to more specific questions about why. What are the reasons why you would see a cohort with that trait? Or what are the reasons why individuals of different age categories would all adopt it at the same time? And these aren't the only possibilities, of course, but I'm just trying to give two examples here of very different categories of process, which I will call forces. And if you know the famous phrase, science progresses one funeral at a time, you may know that comes from the physicist Max Planck, who talked about this in the context of the adoption of controversial ideas like quantum mechanics and atoms, non-Newtonian physics, relativity, things like that. So in the early 20th century, his observation was that having innovated these theoretical ideas, their adoption wasn't a matter of convincing people, as the way he put it, of making them see the light of these new ideas and converting them, but rather simply the demographic process of turnover. As individuals leave, they take their doubts with them. And I think this is actually something that we can incorporate into this framework, thinking about this as one hypothesis for why you see cultural change. And people have talked about this throughout the social sciences as the Planck Principle. And how to evaluate that or test that, I think, is a really interesting question. So for me, one data set that I really like to work in is a very high-resolution behavioral data set coming from a board game called Go. If you know Go, it's a very old game. I think that the earliest archaeological evidence of the game is over 2,000 years old. But we definitely have written records that describe the modern game as early as 1,500 years ago. So it's very ancient, famously super complex, and also quite beautiful, I think. This is an animation that I made that shows a game played by AlphaGo during its famous triumph over human players about 10 years ago. And the basics of the game, I mean, it's not super important for this talk, but if you don't know, the goal between the two players, white and black, is to surround as much of the board as possible using simple capturing rules. But it's famously complex because of the obvious massive space of possibilities here. And as a result, when you look at game records, we have lots of really detailed records of top-level players over centuries of play. It's possible to trace the dynamics of these ideas, strategic ideas, as they rise and fall, and potentially subject them to these kinds of questions like the Planck Principle. So here's an example that I read about and really seized me when I first learned it. What we're looking at here is an opening where there's 8 moves being played on the board in these locations, 1, 2, 3, 4, 5, 6, 7, and then the 8th move here at the top of the board is the subject of a criticism that was made by a very famous player named Gosagen back in the 90s. And at the time, this move here, as opposed to playing somewhere else on the board in the 8th move, was the most popular variant. And I think the second most popular was to play up here, the knight's move. The way that this sequence of events happened was that Gosagen wrote a book. He was commentating on games, and one of the games had this sequence in it. And he said, this move here, this 8th move is terrible. This is a bad move. People shouldn't play it. And he was, at the time, one of the best players of the 20th century, famous, extremely famous. And if you look at the play of top-level players here, so looking at the database from GoGod, each row here is a player's lifeline, and we're stacking the players here, top-level East Asian professional players. I've colored the pixels here to indicate whether they played this 8th move or not in their games. And right around the time that he made this comment in his book, the 8th move here basically vanished. This variant went extinct almost completely. And so I think this is very consistent with the second model that I showed earlier, that people are attending to the advice of somebody prestigious like Gosagen, and they're changing their behavior in kind of like a zeitgeist way as a result of this. And of course, this, if you're familiar with it, is consistent with the mechanism in cultural evolution of prestige bias, the idea that, you know, I might not necessarily know what to do myself, but if somebody who's very successful and prestigious gives some advice, maybe they know something I don't. And so I'll just adopt that or stop adopting it just on the basis of that. That's one potential explanation for what's going on here. So this is the basis for talking about forces in both cultural and genetic evolution, that we can separate out different categories of process and help understand, using formal theory, how those processes are affecting the overall change in the system. So of course, you know, forces here like physical forces, if you're looking at a free body diagram, trying to figure out what forces are acting on a piece of wood on a slope. But you can also talk about demographic forces. So if we were tracking a population size over time, this black line here. We imagine multiple censuses are being taken, and we see this increase and then decrease and increase. We know, I mean, kind of from first principles here, using the demographer's equation, that the population size at time 2, or any specific time in the future, has to be, mathematically, an accounting identity. It has to be the current population size plus the births minus the deaths plus the immigrants in minus the immigrants out. And so that relationship right there becomes an identity that can be used. And in the same way, we can talk about forces in evolution. So, I mean, this wasn't something Darwin originally talked about. I mean, population thinking is clearly visible in his writing, but it took a century of really hard work to eventually reach what I think is the pinnacle of evolutionary theory, which is the Price equation, which was famously discovered by George Price in 1970 or around then, and he wrote it up then. If you read his biography, The Price of Altruism, you'll know that he talked about this as something he didn't entirely understand how he came up with it. Like he described it as a miracle that he came to the Price equation. And it really is amazing. It's something that many researchers had missed for such a long time, but it really allows us to separate out different forces in evolution in a way that we couldn't do before. You may also know that there's a horror movie that came out in 2007 that's about the Price equation called W delta Z, or WAZ. And it's a grisly detective story with a killer who's using the Price equation. So if you're a fan of Stellan Skarsgård, I can definitely recommend it. But other than that, I mean, it's just a curiosity, really. I really do think that the Price equation here is the killer app for also studying cultural evolution. And in my dissertation, I gave a proof of how you can use this in a very explicit way for working with real data sets. And I'm going to give you a rendition of that proof right now. So the basic idea here is a lot like the demographer's equation. And if you're measuring some trait, in this case phi, and we're representing this as an aggregate for a population, like the sum of all body weights, or how many people in the room use a Mac versus PC. So this is an aggregate quantity, and if we're tracking this over time, looking at some phi prime, it has to be the sum of the current phi plus the aggregate of individuals who join the population or the group, minus the individuals who die, so births and deaths, but then also immigration in, immigration out, and then this row term, which would be the total change of individuals who stay, who could be measured between the two time points. I mean, it just has to be. Like, there's no other way to account for the potential changes in the aggregate phenotype. So starting with this, we divide by the population size using the demographer's equation. And we can now represent things as averages. So the average phenotype at time 2, the average phenotype at time 1, and now we can have these vital rates appear. So the per capita birth rate, the per capita death rate, the immigration rate, the rate of retention, which is C here, times the average trait among people in that category. So the average trait among births, the average trait among those who died between the two time periods, and so forth. In evolution, we're primarily concerned with representing change. And so actually, we don't want the average at time 2, we want the delta. So the delta phenotype here, the change in average phenotype. And to do that, we just take the previous equation, subtract the average at time 1. We can add the growth rate here and expand that to the demographer's equation itself. We've done nothing more than just insert these quantities here and reorganize, and we can further reorganize here into this expression. So just moving terms around, separating things out, we end up with the first term here, which is capturing the effect of births on the average, deaths, immigrants out, and also the change of individuals within the population. And this is a form of the Price equation. We've already come up with a proof just from these 4 steps. We can think of each of these as the way that specific forces would be measured if they were acting. You could pick them up by looking at specific terms in this expression. In the canonical form of the price equation, we actually would separate out this first term into two pieces. The first is the covariance between parents' reproductive output and their trait, which is this first piece here. And then the second piece is what's called transmission bias, which is the average difference between a mid-parent and the children of that particular pairing. So, that's how you would get it to the form that you usually see in textbooks. But for all intents and purposes, what we've done is proven that just by an expanded, demographically explicit avenue here. And the cool thing for me was that there's nothing explicitly in here about having this be a genetic trait, or it has to be something non-cultural. It could be anything, including belief. It could be beliefs, behaviors, the use of a particular technology, whether you speak a certain language. And we can subject all of these to the basic accounting identity here, which is given at the bottom. Usually, though, in cultural data sets, we don't have this much information. We don't have every immigrant in or out. We don't have the parent-offspring connections. But we still know quite a bit. In almost every data set that we can consider to be like a cultural archive, we usually know who, if it's individual level data, we know who is involved, and we know what the change within an individual looks like over time. And so we can make a simplified version of the price equation that just accounts for three terms: the influx of new users or authors or whatever, players in Go, their exit from the population, which is also a covariance, and then the average change among those who you could say survive or just persist within the population. They don't have to physically die to leave, they could just retire. But if they hang around, this would be the term that tracks their average change. And the price equation tells us that these things added together would give you the average change overall, which is what we want to study. But I mean, that's enough math. I promise there won't be any more math. The bottom line here is that we have like bookkeeping. We have an accounting system here for keeping track of cultural change and separating it out into different forces or categories of force. So let me give you an applied example. This might make things a little more concrete to help us understand that, I mean, there's really no magic here other than just careful bookkeeping and describing the quotidian events. Right, this is what Darwin figured out, is that evolution is ultimately just the quotidian events taking place in the lives of a population. So we have three authors here at the first time period who are going to survive to the second time period, A, B, and C. We got the first time period trait, second time period trait, and this is, let's imagine that this is a collection of authors, and we're saying whether they use a particular stylistic convention in their work or not. I don't know. They mention cell phones, for example, and if we imagine that we're measuring their work and we say, okay, well, author A here uses it 10% of the time, and then in the second time period they use it 12% of the time. There's a small increase in their average usage. Author B never uses it in the first time period, but then in the second time period they use it 10% of the time, so there's an increase there. Author C actually decreases their usage from the first to second time period, so there's a small decrease here. The fourth author in the census here doesn't use it at all, and they also disappear before the second census. So they have left the population, author D here, and as a result, they don't have a change. So those are the first four. In the second census, we also have two new authors appear, E and F, and they use it 10% and 20% of the time. So that's the full accounting here. If we were looking at the averages between 1 and 2, we'd see an increase, a pretty substantial increase, almost a doubling actually in this usage. And using the price equation, decomposing these pieces using entrances, exits, and individual change, we can see that the primary driver of this change, the increase here, is due to the entrance effect. These two new authors coming in have by far the largest effect, just using the basic accounting here. You also get an effect from the exit as well. Losing author D means that the average goes up, right? Because author D doesn't have the trait. And so when they leave the population, they take their not having the trait with them, right? kind of like what Max Planck was describing. And so that is a process. That's a force that's acting here, and we can measure it using the exit effect. And then there's also a slight increase from the individuals on average adopting the trait more between the two time periods. And so you can just check with accounting math here that this and this are the same number. They have to balance because that's the way the price equation works. And so we have this bookkeeping system basically for calculating the forces, the effects that are happening. So let's get away from the numbers and just talk about this graphically. If we were doing these calculations over and over again between censuses, from first census all the way to like a 17th census here, and we saw this topical increase here in some frequency going up, and then peaking here around census 11, and then decreasing again. Using the price equation, we could decompose each change, each delta, into these forces, and we're representing these here as these colored bars to sort of show which direction the force is pointing. So if it's an entrance effect that's pushing up, it's above the black line, and that's taking place for the first 9 censuses or so. You have this process by which new individuals are entering the population, and they consistently have the trait more than the existing average, and so it's driving the average up. And so that's happening over and over again until you get this reversal. And so right around this period of time here, you have this flip, and individuals who are entering the population now have the trait a little bit less than the current population, and that causes the average to go down. And this becomes increasingly strong. You can see here that the blue becomes quite negative if you're looking at the delta here, such that the decrease is due to a negative entrance effect. So it's being cohort replacement is taking place. Why that's happening, I mean, that's the second order question, right? We're just saying if this was observed, we would say, oh, that's kind of cool. We see that it's definitely not due to exits, right? Exits are a relatively weak process here. And it seems like they have to be, which is for really interesting reasons I can get into if somebody asks me about it in the Q&A. Also, we could say that individual change, people adopting or not adopting this topic within the population, seems like it's a relatively weak force. It's always present, it's always positive, but it's not quite there. It's not quite strong. Yeah, let's try to get this to a little bit more concrete examples here, just thinking hypothetically still. So if there was some kind of event that took place that affected individuals in a cohort throughout their whole lives, like Eric Maria Remarque experienced the horrors of World War I, and it affected him very deeply, and he wrote about it for the rest of his career with things like All Quiet on the Western Front. In that kind of a situation, you would expect to see very strong entrance and exit effects, because cohorts are clearly what's important here, that this particular cohort was affected by some event, and they carry this with them into the future. So if we simulate, if we created a data set that had that process going on, and then calculated the average here, we could use the price equation to do this decomposition on it, and we would separate out the contributions from entrances, exits, and from individual change, and it's exactly what we would hope, that you see a big entrance effect as they arrive in the population from their cohort, and then as the cohort is turned over by new cohorts, that average goes down. So they don't change themselves, they're consistent throughout their lives, but you see the effect of the cohort itself, the cohortiness of the data, just from the decomposition. Let's imagine sort of a more zeitgeist-like phenomenon where something happens, like the moon landing in the 1960s, that just seizes everybody at the same time. And individuals, young and old, are suddenly talking about space and space exploration. There's movies being made about it. There's TV shows. It's in the zeitgeist. So in that scenario, you really would expect there to be this burst of interest, even among the oldest individuals who are in the population after this event. And if you simulate that, you create a kind of a zeitgeist spike here and do the decomposition, you see a really big individual change effect. So entrances and exits are not part of the story here. And that's the starting place, I think, for some really interesting questions about why. So taking this to real data, going back to the Go data that I talked about earlier, I found in my dissertation work that Max Planck was basically wrong about Go, that it's not progressing one funeral at a time in terms of strategic turnover. Players are actually changing their behavior as new ideas appear. They see the light as strategies appear, especially recently with the arrival of AI, and they adopt those strategies systematically. And so it's very clear from the decomposition that the primary loading is on the individual change term rather than entrances or exits, which I think is really remarkable. And this is important for kind of connecting it to existing cultural evolutionary theory. So I've been talking about the price equation here, which hasn't really penetrated, I think, in the overall framework. So like if you look at work that overviews the theory on cultural evolution, the main focus is on individual decision-making and social learning strategies, for example. And there's a ton now. I mean, if you look at these lists, they're getting longer every single year, it feels like. Conformity and prestige, uncertainty bias, that kind of thing, success bias. But what's kind of important here is to remember that none of these things will be important in a system where cohorts are very important. If you don't see the kinds of phenomena like we see in Go, where people are changing their behavior a lot, then there really isn't a big scope for any of these forces to make a contribution because people aren't changing, at least not within the population. I mean, when they enter the population, they might have been learning as juveniles, for example, and then it becomes a really interesting question about what's going on then, before they're in the population. But within a population, if there isn't much individual change, then there really isn't going to be a lot of social learning going on, right? And so as an explanatory force, I think we can kind of rule things out in that kind of a system. So I'll give you an example where that seems like it's taking place. This is work I'm doing with my postdoc, Oleg Sobchuk, looking at large collections of fiction that we have full texts on through the HathiTrust database over the course of about a century of Anglophone fiction. So it's not just from the United Kingdom, it's also the United States, Australia, and other countries that publish the work in English. And in about 19,000 works here, we can track the rise and fall of particular ideas or clusters of ideas that we can call topics. So using topic modeling algorithms, we can identify associations of words within the text that we can look at and kind of group together as thematically connected. So you got gun, shot, rifle, killed, shooting. This is topic 59 in our model here that came out of the algorithm. And then topic 49 is marriage, wedding, bride, happiness, engagement. So each of these here we can maybe interpret and assign a name and say this is about love or romance, marriage, and this is about shooting or guns or violence or something like that. And we can track this over time and see how many works from a particular author use this topic as a frequency, and then how does that change over time. So let me give you what it looks like when we actually do the decomposition here. So here's two different topics that came from the algorithm. The first one we looked at and we said this topic looks like we could call it war, given all the words that are associated with each other. In the context of war, we're tracking this from the 1850s all the way to the 1940s. And in English fiction, you see this increase here during the American Civil War. And then another notable increase in the 1910s, which is, of course, coincident with the Great War, World War I. And doing the decomposition, asking, how much of this change is due to new authors appearing or authors leaving the sample in their publications, and how much is it due to authors switching, the basic answer is that it's primarily driven by authors switching, especially in the 1910s. You have many authors now adopting and incorporating the concept of war into their works because this is presumably, obviously, salient to everyone's lives. It's very different with something like the Wild West. This is another topic we look at. Just looking at the words that are nominated, we could say, oh, this is about Westerns as a topic or as a genre. Here we have, looking at the same time periods, we have this burst of interest in Westerns in the 1800s that comes from authors adopting it as a topic. So they previously wrote about something else and they incorporate Westerns into their work. And I mean, there's a little bit of up and down here, but on average, the increase is due mostly to individual change. That switches in the 1900s. You have this increase now due to new authors arriving who, this major force here for a couple periods is that they're coming in with their first works writing about Westerns. And it's really neat how you have this kind of transition. You got this steady increase in the topic, but for the first period, it's people switching to it. And the second period, it's like the second generation who are native Western writers. They're coming in with this existing framework. But then things change. You can see here that there's a decrease in Western fiction or focus on the Wild West. And for the last couple periods, the exit effect is the strongest. This is authors leaving the population who wrote about Westerns, and they're taking the topic with them. Like there isn't anybody to replace them writing about Westerns in the 1930s. And so it just becomes less popular because, I mean, literally it's one funeral at a time or one retirement at a time in this case. So hopefully you can see that doing the decomposition, we get different stories for different topics, but we can get this overall sense of why things are happening, right? Which I think is really cool. So Oleg and I asked this not just for specific topics, but like all the topics that we could look at in this data set. And we found that overall, on average, exit effects tend to be extremely weak. Looking at like a ternary plot here, there's almost no contribution from exit effects. Entrance effects and the individual change effect tends to be about equally balanced. In some cases, the entrance effect is stronger. So to answer the question, does literature evolve one funeral at a time? We said no. If anything, it's rather one birth at a time. And we're currently continuing this by looking at other data sets. We've got French fiction and also Dutch fiction. We're subjecting to similar analyses. And not to spoil anything, but it seems like we're seeing really consistent patterns here, that exit effects tend not to be important, and the entrance effect being the most important in both data sets. But this is very preliminary research, so I can't say that that's definitely going to hold. I'm doing a similar analysis with another postdoc, Peter Tinnitz, and we're looking at European books here from the Heritage of Printed Book Database, HPD. And here we don't have the full texts, but we have a much longer time period going back to the 1400s, and we can look at things like the author themselves and aspects of their work, like the title, and also what language they're writing in. So Peter's from Estonia, and if we look at Estonian publications during the last 4 centuries or so, we can look at what fraction of work is being written in particular languages. And we see a relatively interesting story here. You have this period of time in the 1600s where most work is written in Latin, transitioning to German, and then the rise of Estonian itself, the vernacularization of literature during the late 1800s and 1900s. But of course, there's some up and down here. There's also the role of Russian, the purple color here. So, I mean, this is like a standard analysis, right, in a cultural change project, looking at the diversity of some topic. If we take evolutionary ideas in, using the price equation, we can decompose trajectories and say a little bit more. So if we look at just the topic, quote unquote, of Estonian, if somebody is writing in Estonian or not, and then tracking that back several hundred years, we see the rise of Estonian as the language that work is written in, starting maybe in the mid-1800s. But looking at the decomposed patterns, we can see the balance of this is through demographic turnover, that authors are coming in and they tend to be writing in Estonian as their first works. That changes, though, in the early 20th century, and specifically the outcome of World War II and the Soviet occupation of Estonia. So at this point, you have a big reversal. There's a decrease in Estonian as people switch to Russian, and you can see from the decomposition that the switch is being driven by individual change, that authors are actually switching to Russian rather than having new authors come in. So this is taking place throughout the Cold War until the end of the Cold War and Estonia's independence, and then it reverses again. And you have an increase in Estonian as authors switch back. So isn't that incredible? I mean, you can just see history here in the decomposition terms. Like it's kind of implied, of course, by the overall trajectories, but the forces give you a sense of what the dominant process is in the system. We're doing something similar with German in cities like Leipzig. You got a long history of publications here, and during this time you also have a big increase in the German language as the language of choice. Here it mostly seems like it's being driven by individual change. And we can use this method, I mean, just zooming out a little bit, to talk about all sorts of different kinds of changes. Basically, anything you can measure that you think might have some interesting story behind it, you can separate it out as long as we have individual level data. So working with Monique Borgerhoff-Mulder with data sets from East Africa, we are focusing on the question of what causes populations or communities to become richer or poorer over time. And here we can track individual households as they break apart, they form, they split, and persist and emigrate out. And we can use each one of those terms in an expanded form of the price equation to measure the contribution of each mechanism to the change in the average wealth in the community. Yeah, this is, I mean, it's very different, of course, than looking at literary change or strategies in the game of Go, but I think it's still, you can still understand it very meaningfully in terms of the price equation. This is very preliminary, though, so I can't tell you more than this at this point. Yeah, so I think there's a real program here overall, and I've gotten some really good collaborators over the years who feel the same way. So Oleg, who was the lead on the literary topic project, is leaving next year to start his own research group at the Max Planck for Empirical Aesthetics in Frankfurt. And using this kind of decomposition force approach is going to be a central component of his program there. So we're going to be hopefully doing a number of projects now, zooming out and looking at different kinds of artistic evolutionary change. Here in Leipzig, we also have the Department for Human Behavior, Ecology, and Culture, led by Richard McElreath, which is explicitly organized around using the price equation and applying it to measures that we can get from field populations over the course of decades. And so this program here also, I think, fits into this overall framework of trying to measure the forces that are behind cultural evolution. And even though we're only partway through this this project, I think we're starting to get some really interesting results. So in particular, I've been working with the Chimane Health and Life History Project to organize longitudinal data sets of what's being measured in the horticultural population in Bolivia. And looking at cultural topics, like in this case, we're looking at a population that mostly still speaks an indigenous language, Chiman. We can see something like the spread of Spanish within this population, and to decompose this using the price equation using the same basic mechanisms as I've already described. So this was work done by my graduate student, Rihanna Miniature, looking at the way in which the Spanish-speaking and non-Spanish-speaking members of the population have reproductive contributions into the language community. So it is the case, we found, that male Spanish speakers tend to have much higher age-specific fertility rates than non-Spanish speakers in this population. And there's also a really strong consistency between the language capacities or language fluency of parents and offspring in this situation. And so through that mechanism, we can see that there's scope for strong entrance and exit effects, or a strong covariance between reproductive success and a particular cultural trait. And of course, the reasons for that are very complex and interesting. The ability to get into markets and command access to wealth, have different social networks. There's a number of reasons, of course. But as a basic question, we can definitely say that reproduction and fertility are key components of understanding cultural change in this context, even though this is preliminary results as well. So to kind of sum up, the basic idea here is that we can use this approach to measure the driving forces behind cultural trends. And I mean, it's not going to tell you the full story. It's just a first order explanation. But it definitely can rule out specific mechanisms. You can say in a system that's being driven mostly by cohort change, we don't need to necessarily worry so much about things like conformist bias among individuals because we know it's not going to be an important force. Conversely, if we see that individual change is really driving everything, or something else like that, then things like the Planck Principle, the idea that there's some process of one funeral at a time or one birth at a time, that might not be especially important, and we might not need to worry about things like the differential reproductive success. So the ability to rule out mechanisms, I think, is really the big value you get from doing this, and you would do it with the price equation. The Price's theorem itself seems, to me at least, to be the obvious way to go about doing this kind of analysis, because we think culture is evolving, just like you would do with a genetic system. So to kind of sum up here, we've got this project here of doing this approach, and we're very interested in collaborations. If you think you have data that could be used for this kind of analysis or some ideas to develop the theory, I would love to talk to you. And I can kind of close here by talking about some of the wilder things that you can get into here in doing this kind of approach. I mean, the basic question here is, why would you see different kinds of modes of trajectory forcing? So some systems seem to be driven by cohorts, other systems not. What is it about the cultural traits that we're measuring that lend itself to that? There's definitely systematic changes in the way that culture is inherited over the last several centuries, and so we might ask if there's some systematic shift. Maybe things seem like they're becoming less cohort-driven now than in the past. And I think especially we could look at the last 10 years at the arrival of AI and more recently LLMs, and wondering if that might be creating a lot more individual change as individuals are willing to adopt or not adopt things as a result of interacting with AI. These are pure speculation here. I have nothing to back this up other than my opinion, man. But I would love to talk to you more about this later. And I would thank you also, and also thank my amazing collaborators for all of this stuff. And I look forward to your questions. Thank you.
You first. Anyone in the room?
If anyone in the Zoom would like to ask a question, you can go ahead and unmute yourself.
I'll ask the question. Naturally,
Yeah, you should unmute yourself.
you should mute your laptop. Ready? No. Naturally, I'm wondering whether I can apply any of this to Capuchin data. And of course, I haven't had a chance to look into my data with this question in mind, but do you have intuitively any thoughts about, I mean, I have behavior variation. I don't know in advance whether it's cultural or not.
Yeah.
It seems like it would kind of need to be cultural for this to work. Do you have a feel for how many individuals, how big the population size might need to be? How much behavioral variation there would have to be in order for this to be a viable method to apply to it? Like, I'm just envisioning there might be some traits where there's one innovator and maybe 3 or 4 out of 30 pick it up and then it doesn't go anywhere. That would perhaps be a little nebulous, right? Any thoughts? I mean, you have these huge, wonderful data sets. I will probably not have as huge and wonderful a data set. What is your intuition about whether this would be even worth investigating?
Maybe. I mean, you're exactly right.
Now we need to have him back on.
Can you hear me? Yeah. So the question is there some kind of a lower limit here on sample size to get anything kind of clear in terms of a signal? There definitely is, I think. I mean, you can see even in the graphs that I was showing that actually let me try screen sharing. Can we do that? Um, is that something people can see now?
Yes.
Okay. So yeah, in the graphs that I showed, there's definitely a lot of noise if you want to think about it in that way, especially earlier in samples. So maybe you can get this with the HPD stuff. Like here, you're talking about very little work. Actually, the denominator is quite small for these calculations, and so it's kind of bouncing all over the place. And that's especially true, I think, in this sample where the earliest years are quite noisy. So yeah, I mean, it could be the case that doing a decomposition on Lomas might show with just a few individuals that you can't really tell something going on. So yeah, I think that's that's a kind of a disappointing answer. You know, I wish we could, right? I wish we had giant populations to do this analysis with. Um, but I mean, to kind of put it back in this made up example here that I had with the little lines at the beginning, um, it could be like this. I mean, you could have some small sample here, just like these little cartoons with the timelines here. There's only, you know, like a couple dozen individuals here. Um, but you do get a relatively clear picture of some kind of a differentiation of process. And depending on the circumstances, it's possible you could make some interesting inferences with a small sample too. So I wouldn't rule it out. I mean, I wouldn't expect it to look like the same kind of analysis that you'd see with the historical records of bibliographic output. But the questions that you could bring into this, I think, are the same, and you might be able to find something interesting. If there's, you know, I mean, evolution works at the margins, right? That's the basic idea. So if there's too much noise, maybe there's nothing to say, but it's possible that there could be some signal involved. So yeah, anyway, I'm not ruling it out completely.
Hi, thank you so much for being here from Germany. I have a very simple question to ask first and then a different question. My first question is, and maybe it would be helpful to go to the slide to answer. But when you were making for example, from the book, from the English literature analysis, how were those word families originally defined?
Yeah, let me go to that right here. Uh, Here we go. So
Yeah, like
yeah,
this.
this is using this exactly it. So the goal with this particular algorithm is to nominate clusters. So we pick a number of clusters that we want at the
Right,
beginning. And so
right.
for our project, we chose 200.
Yep, yep. But how do you define the words how are those clustered? Like, how do you decide that streets, houses, and windows are words that group together?
Oh, well, that's what the algorithm does. And
Okay.
it's mostly based on co-occurrence within a page.
I see. Okay.
Right. So it's just saying, you know, if you look through these words, what words consistently show up together and travel together, and that kind of implies that they're part of some kind of a thematic structure, right?
Okay.
Um, but I have to say, I'm definitely pushing the limits of my own understanding on this because this is Oleg's specialty, right? So in digital humanities, doing topic modeling with these algorithms is something that he brought to the table on this project and led very skillfully. So I can describe it, but I can't tell you exactly what you would do myself because I didn't do that part of the project.
That's fair. And that helps me though to understand the co-occurrence idea.
Yeah.
Cool. And then
And
oh yeah, sorry.
yeah, go ahead. Go ahead.
But I'm gonna switch to my second question. Is that we good on that? Yeah, okay. So my second question is, I know that I'm curious about the application of this particular idea to archaeological data sets. I know that in the I'm not a historical archaeologist, but one of the things that stands through from undergraduate and graduate education when I did it was this idea of the battleship curve. So looking
Yeah.
at change in artifact usage over time, right? Particularly historic archaeology, they did the New England gravestone, tombstone thing. And I was curious if you have, or if you're thinking about endeavors where you look at archaeological data to understand this, maybe the outside of the historic record or the current record.
Mm. That's a great question. I think I have to be a little pessimistic in this particular context as well. And I do this with, having great relationships with my archaeological colleagues here in collaborating on other things. But I think that the basic limitation is that we're not actually measuring so much the traits as the individuals that are behind the traits.
Right.
Right. And so we're looking at the way that those people change over time. So like in this example here that I've got, I mean, that's basically a battleship curve, right? Like if you were looking at material record, somebody's producing artifacts or they're leaving physical evidence of some kind that can be measured. It could look like either one of these things in terms of the actual productive output of like, a tool maker or an artisan or something. And it would be difficult to tell with just the physical evidence, right? There's this limitation with this approach that kind of implies that we're really tracking individuals and when the individuals arrive and when they leave. And those moments when there is a departure, there's demographic turnover, that's the component where we're trying to really get into. But the requirement, at least as far as I've been thinking about this so far, is that we have individual level data on the people producing the emissions, quote unquote, whatever specifically we're trying to measure. So yeah, that would be a limitation of this method.
Thank you.
We have a question from Zoom. And then Emma.
Yes. I'm sorry. Was that for me?
Yes, sorry.
Oh, I'm Ted Sato. I'm sorry. So I had two questions that may appear unrelated, although they're related in my mind. You've used this in this talk to talk about distinguishing between cohort succession and zeitgeist. And then you said this will lead to, or may lead to, or hopefully will lead to, insights about the why. And I wondered if you could talk a little bit about sort of the next big step, where you go from this, because I find the cohort succession versus zeitgeist very, very interesting. But I'm also really interested in how you then start looking at causal mechanisms. And let me pose the second question, which might appear unrelated, but you can see why it would be related. I'm thinking this would be really interesting to apply these techniques to United States Supreme Court opinions. So we have all of those things in database, and we could do very much the same kind of analysis, cohorts versus zeitgeists. And then there's the why. And I'm really curious about what we could infer from about the why as to how law evolves.
Yeah. No, those aren't unrelated at all. I think those are great questions. I'd actually thought about that exact thing as well, jurisprudence, and trying to do some kind of a analysis of, documentary records. It totally makes sense. I mean, you could also think about this in the context of like the, legislature and the turnover there as well. Anything where you're tracking individuals and seeing how their effects of leaving or entering play a role. So let me go to a slide that I didn't have in the set because I think I can get a little bit more detail here. So I added a slide here. So this is a paper I wrote as a result of my first decomposition ever, which was exactly, I was worried about this cohort thing. with Go. And then I realized Max Planck was wrong, that there really isn't, seems like there isn't really any strong cohort story to be told here. Um, and in the world of behavioral science, I think that when you can make a clear case that individuals are making choices and that makes a big difference for the system, which we know now from the decomposition, uh, that we can start motivating decision-making models and using statistics to try to estimate what those decision-making models might look like. So in my 2014 paper, I argued that because individual change matters so much, decision making matters a lot, we might expect there to be strong social learning biases. And so I made the case that in in the context of adopting strategies, there's this process that looks a lot like conformist bias, that individuals are not just adopting things because they're adopting things that are popular, but they're doing so at a rate that's more than the popularity. And the implication is they're kind of leaning into the popularity to mine uh, information out of. They think the popularity itself is a signal potentially of the value of a trait because they don't know how good the trait is. So that's something that I found that was sort of motivated by the decomposition. The second stage, right? So first stage, I find that there's a big individual change term, and I start targeting that. And I say, okay, what else do we know? Like, what about their social network do we know? Or what kind of information do their cognitions have when they're making their decisions? Do they know how well the trait is doing from their peers? Do they know who is using the trait? So you can really start building in mechanistic models that get, much richer understanding of the system. Um, but the starting place is to know that that term is important, right? Like if I had done the decomposition and it turned out that it was really one funeral at a time, that Go players are just these, inveterate users of whatever they started with in their careers, then it basically is a waste of time to try to do this kind of work, right? Like we should be focusing more on um, how people matriculate in. Like what are the reasons why somebody goes into a professional league with that trait versus not? Or how do they socialize when they're younger before we can measure them, like as kids maybe. So that's a totally different framework, and you can imagine studies being designed that start from that place and say, okay, in a cohort-driven place, we really need to focus on, things like the idea that there's events that might be causing the cohort to all have that same shared experience. Like if you're looking at the Great War, I mean, there's a cohort of people clearly who were participants in the war and they were deeply affected by it versus people earlier or later. Um, and I mean, we can all think of other similar examples, right? That, like Kurt Vonnegut writing about the themes in his work as a result of being in Dresden during World War II and experiencing the bombing there. Um, so in that context, you wouldn't necessarily be, trying to do like models of decision making because you don't think necessarily that that would be a good place to start. But the bottom line, at least in my head, is that we can sort of get hints as what we should be looking at from this kind of analysis, and then start building more grounded, richer statistical approaches to try to understand exactly what might be going on. And that might involve targeted data collection or just speculation based on because we don't necessarily have the data. And yeah, I really do think like it is exactly as general as you're thinking about it that we could apply this to see how bands change as different members of the band come and go, or looking at, sports teams as members cycle in and out over the course of many decades. Uh, it's so general, right? As if we have something we think we can measure, and in the context of like a legislative record, you could do topic analysis or sentiment analysis is another one that's very common to try to measure like how angry something is. And you could do a decomposition too to see how angry do people get? What's the average anger level in Supreme Court opinions with the arrival of certain individuals who shall remain nameless? Um, and that's a totally, maybe you'd have a small sample size there too, like Susan's Susan mentioned. But I think it would be neat to try at least, and you would certainly get something interesting on a legislative level where you have a big, hundreds of people that are cycling in and out over time.
Um,
I think it was your last slide that said that you were interested in measuring zeitgeist and like maybe a shift towards more zeitgeist in society. And I was just wondering how you're going to measure zeitgeist, because I feel like so much zeitgeist happens on the internet. And I think internet spaces, I think you could make an argument saying we have more zeitgeist, but I think you could also make an argument saying we have less, because internet spaces can be very fractionated and niche down.
Yeah.
Whereas like the moon landing, there was like 3 main news channels, so like everybody was going to experience that zeitgeist. I just wondered how what you've been thinking about in terms of that space.
Yeah, that's a great question. I think you're exactly right. I mean, the media fractionalization has been probably the most interesting theme of, just my media consumption, just realizing that, when I was a kid, I was watching cable and like everybody else was watching cable too. And so we had this shared experience that we often don't really seem to have anymore. So I have a paper that I did recently. I wonder if I get the slide for that here. Yeah, I did. So, in the context of Go, sorry to keep bringing it back to Go, but it's such a great data set. One of the things I was very interested in is looking at something that we have data on for hundreds of years. What do we see when we get to the closest period of time where you see this big impact from new kinds of media and especially the internet, and then most recently the arrival of AI. And so I've got this project that looked at strategic diversity in the game, and also the sort of how changey every single time period is using a measure called divergence, which is it's just a comparison of how much difference there is. Um, and we can really do, these deep time comparisons and say, okay, well, yeah, like in the 1700s, you're looking at the amount of diversity that you see behaviorally inside the strategies of people's play. And you can compare that to the 20th century, when people are primarily consuming through books and through magazines, radio. And then you can also compare that to the early 2000s when people are transitioning to sharing strategies through online play. Sorry, that didn't mean to advance that. And generally speaking, it seems that the arrival of the internet actually coincides with kind of a decrease in overall diversity, uh, which is, I think that speaks to the idea that there is a clear increase in the connectivity that individuals are experiencing. And so um, I think differentiation makes a lot of sense in other contexts, but at least in this particular case, the more connected people are, it's coincident with a decrease in the diversity that we see in strategies. But I mean, the strategies are also getting better, right? But one thing that I thought was really neat, I was looking at this also using, there's this literature in phenotypic evolution on how you measure the speed of evolution. Like this is the phrase that's used, the speed of evolution. What is that? What is that way to do that? And so using techniques from that literature, I tried to apply this to looking at turnover and strategies in the game of Go and mapping that onto historical events. And there was, I thought, some really neat transition points, just measuring the rate at which you see a turnover in strategies. And the first one was that there was a big increase with the end of the Chinese Cultural Revolution in the 1970s. And that was because of an influx of Chinese players who had been previously absent from the database because during the Cultural Revolution, Go was not popular in China. And so that it was just not being played, I think. So they show up again at the end of the Cultural Revolution. They bring in a bunch of new ideas in the early 70s, and this leads to a very rapid burst of innovation. And then when the internet arrives, we also see an increase in the speed of evolution. There's a decrease in the diversity, but there's an increase in the speed of evolution because things are moving quickly through the population. And that also increases all the way up to the arrival of AI, where there's this kind of peak that exists, at least as far as the model is concerned. I'm not super sure about these last 3 data points in this particular graph. It's possible that that's just a sampling issue, and that if we just ignore those, then this seems like it decreases too much. Jury's still out on that one, I think. We'll just see with the fullness of time. But my general sense is that the reason we could say it's more zeitgeisty, or we could speculate, without any real concrete evidence that things might be more zeitgeisty, um, has more to do with the speed at which information can move through communities. Even if they're more fragmented, um, it's possible that they can still be touched by large-scale cultural movements that are coming through some kind of a social network. Or maybe not. I mean, these are just like thrown out ideas here for how you might approach this topic, and it's possible that these are all wrong ideas, and there's a better way to do this that I'm missing. So I would definitely enjoy some feedback on this as well. But that's how I would approach it.
Brian.
Hi, Bret. Thanks for your awesome talk. I hope you can hear me. I, as you went through your talk, you were using the demographer's equation as a kind of foundational model to build from and modify. And I'm just wondering, kind of circle back to the demography of all this, whether or not you've explored versions of your decomposition that do involve some actual demographic rates in terms of, the age of an individual playing a role rather than their age at the entrance. Like what I'm thinking of is if, for example, age ranges, there's some kind of selection effect across time where, if the population of possible authors is restricted to a certain range of ages or a certain gender, let's say, and then through time, publishing norms change and you have a broader spectrum of the whole population contributing to your sample of published authors. There's possibilities that, for example, if the set of published authors is more representative of the actual demographic population, that your published set would be a more accurate representation of the demographic population's, let's say, likelihood of first publishing in a certain language or changing, or the likelihood of cultural change. So, and I'm wondering, basically, just to try to push a little bit on the use of your terms of birth and death as an analogy, and as you seem to be doing, versus actually having a model that includes some recording of the age of individuals, their birth dates, and their actual death, to get a sense of how, I mean, just thinking that an individual's age is probably going to be influencing their likelihood of being open to cultural change, let's say. And you have those sort of sampling effects, and how you might, have you pursued those kinds of models where you're thinking about a broader population that's being selected upon, that is then contributing into your sample, and how that selection effect could play a role in these?
Yeah, those are great suggestions, Brian. I could say that I definitely considered some of those, but other ones are actually quite new to me, and they're really compelling. So thank you for mentioning them. The age component is, I think, clearly the most obvious thing to try to build on. And in the work that I'm drawing from, when I started doing this stuff, primarily from Tim Colson and Shripad Tuljapurkar, their version of this approach using phenotypic measures like body weight was always explicitly age structured. Like they had a version of the decomposition that was using the multi-level form of the price equation, which, I mean, this is really insider stuff here now. But you can basically take the equation that we used and make a version of it for every age category. So people are coming into an age category and they're leaving the age category and they're changing within the age category if they stay there from time period to time period. And then you have flows between those age categories, which are also measurable. And then the age structure itself is also changing because of the relative balance of individuals within, lower or older age categories. And so you can imagine a situation where we sort of fix everything so that people reliably move through an age system, and they always have certain traits at certain time points. Like what's that famous quote that I think Winston Churchill had this thing about like, it's the case that everybody's liberal when they're young, and conservative when they're old. That was just like a claim that he made. And I think there's some evidence that happens. People become more conservative with time. And so if you imagine that kind of a process is going on where people are moving through a developmental cycle that results in them embracing certain beliefs, you could get systematic cultural change if there was a change in the age structure, right? Because the average would be changing as the population gets older or younger. I don't know, maybe too many boomers, and that explains everything, right? But that kind of a process is outside the calculus that you only have that I'm describing here, right? So we're not looking at age explicitly, and so changes in the age structure would show up through they would show up through entrance effects, which is not as articulate as it could be, right? So if you did have an explicit version of the equation using individual age categories and then having the summation of all these different processes, you could potentially detect things that you can't see with the single level terms. And I think that's a great idea. That's absolutely where we're going next. I hadn't thought about the representation issue, but now that you mention it, I mean, it makes total sense. Like in the data set that we're looking at here, with the rise of popular fiction or popular works being written in the language that people speak in their native country, the vernacularization process, you really are seeing a shift away from sort of this intellectual caste who only use Latin as their publication language, which is extremely insider and not representative of a typical member of the population, to a much more populist kind of literary world, right, where people are writing in the language that they speak every day. And so that's absolutely interesting as a way to interpret what's going on here. And I guess you could imagine just kind of making some speculations here sorry, I don't know why the mouse is doing that. That's almost certainly what's going on here. That as you have this increase in Estonian, like people writing in Estonian in Estonia, that really what's going on with all these blue boxes here are the opening of this niche to a more popular set of writers who are speaking to a more popular audience. That's potentially an interpretation. And I don't know if that's subjectable to statistical analysis. Maybe there's some way to look at that, like, the birthplaces of these people, which we do have actually. Peter's done some analysis of where people come from. But even just descriptively, just looking at people's biographies and describing this in a qualitative sense, I think that would be a really neat place to go. And the gender restriction thing, I think, of course, would also make total sense, especially when it comes to the topics we were looking at, like topical analysis. So, yeah, thank you so much, Brian. That's great stuff.
Right.
I feel like there was another hand over there earlier.
It was mine, but it got answered in the
Oh, okay.
question.
Any final questions? All right. Thank you for your talk.
Yeah, thanks for
Yeah, thanks so much.